Question number 44. Here each side represents equal resistance, let's say R. So there are 12 edges and there will be 12 resistances. Points A and H, they are along the body diagonal of the cube. Now from point A, if let's say I connect a battery of voltage V in order to find out the equivalent resistance of this system. Let's say A is attached to higher potential and H is to a lower potential. So the current flowing through this branch, let's say is I. So I is entering, I will exit also. Now what will happen to this current? Let us see the three branches from which point A is dividing. So let us assume this branch is 1, this branch is 2, and the branch which is going vertical is 3. Similarly, from H, you can assume the one which is parallel to 1 is marked as 1 dash, the one which is parallel to 3, it is marked as 3 dash, the one which is parallel to 2 is marked as 2 dash. Now you can see this path 1 is divided further into two branches. So one is divided into this one and this one. Now this one is attached to 3 dash and this one is attached to 2 dash. So you can see this one is dividing into two branches and these two branches ends are connected to 3 dash and 2 dash. So 1, 3 dash, 2 dash. Similarly, this 2 is also divided into two branches. One end is attached to 3 dash and the other end is attached to 1 dash. So again 2, 3 dash, 1 dash. Similarly, you can check up with third one. The third one is divided into two branches. Each branch end is attached to 1 dash. This branch end is attached to 2 dash. So you can see there is some sort of symmetry. So this one is divided into two branches and we have seen that it is attached to 3 dash and 2 dash, but also this branch is also attached to a branch coming from 2. This branch is also, not only this branch is joined with 3 dash but also with branch coming from 2. Similarly, you can check this branch 3 is divided into two branches. One is attached to 2 dash and the other is coming from 1. You can again see here 3 is divided into two branches. One is this, the other is this. So this branch is attached to a branch coming from 2. So if you examine like this, you will come to know that each of the branch, whether it is 2, 1 or 3, further divided into two branches and again joining with 3 dash, 2 dash and so on, you will see that they are all very similar. They are all, you can say, symmetrical. So that is why this I, we can assume, can be divided into 3 equivalent currents because the pathways further are equivalent. So this I is divided into I by 3 going to path 1. To 2 it will be again I by 3 and to A will also be I by 3. Now this I by 3 is again divided into two branches like other 2 and 3 also. So this I by 3 is further divided into two parts. I by 3 should have equivalent currents divided into. So it should be I by 6 here. I by 3 is half is I by 6. I by 6. Similarly, this I by 3 is divided into I by 6 and also I by 6. this I by 3 is also divided into I by 6 and I by 6. So let us now consider a loop containing V to find out what is V upon I. V is the voltage applied across A and H, and I is the current passing through this cubic resistance. So let's calculate V upon I. For that we need to consider a loop here including V. So from here to here the change is V, and then from A to this point it will be minus I by 3 into R. R is the resistance of this path, this branch, and then from here to here it is going to be minus I by 6 into R, and then from here to here it will be further minus I by 3 into R, and the loop is over. So the sum should be equal to 0. So this is minus I by 3 minus I by 3, it will be minus 2I by 3. Let's take all the negative term on the right side. I get I by 3 plus I by 6 plus I by 3 into R. So if I take its LCM and all, I get 6 here. This is 2I, this is I plus 2I, and this implies this is 2I plus I is 3I, 3I plus 2I is 5I. So if I take I common, V upon I will be equal to 5R upon 6.